Today, more and more people are leaving the city to enjoy the beauty and tranquility that nature offers. Homes and communities are springing up where once only trees and fields stood. While living next to wildlands may offer serenity, it also poses great risk. A wildland environment is a fire environment. Fire in wildland urban areas is inevitable. It's part and parcel of the natural order of things. But that doesn't mean we are helpless in the face of the flames. We may not be able to stop wildland fires from occurring, but we do have a choice about whether or not our homes will survive a wildfire. And the steps we need to take to protect our homes are actually surprisingly simple. Are caused by flames and by firebrands. Flames directly transfer enough heat to ignite the home. This transference of heat can occur by thermal radiation, when a fire conveys enough heat to nearby fuel so that the fuel combusts. Or it can be caused by convection, when fire comes into direct contact with the fuel. Homes can also be ignited by firebrands, burning embers that fly through the air, land on combustible materials, and directly ignite them. Scientists also investigated the relationship between time and fire and dispelled another widely held misconception.
When we watch a fire spreading through the forest, it may last for hours and hours, but it doesn't last hours and hours at a particular location with those big flames.
It is the twigs, needles, grasses, and other fine fuels that allow forest fires to burn, but it doesn't take long for that material to be consumed.
It's not that the big flames don't provide a lot of heat, it's just that they don't provide that heat over a very long time. So, for example, the big flames come up in some proximity to a house with wood walls, and we find that, yeah, it's really intense, and certainly intense enough to cause human injury, but over the period of time that they last, on the order of 60 seconds, it's not sufficient to ignite that wall.
We assume that a fire which burns humans quickly must also ignite wood quickly, but our intuitions are misleading. Humans are far more susceptible to injury from heat exposure. Because most crown fires consume their fuel in a given area in about a minute, they simply burn out before they can ignite most homes or structures. Other experiments revealed an equally surprising finding about fire and distance. Crown fires, even intense crown fires that burn at a distance greater than 100 feet, cannot provide enough radiant heat to ignite a structure.
It gives us an opportunity to change where that fire goes by somehow changing the situation so that it doesn't meet the requirements for combustion.
Armed with this information, Jack formulated the home ignition zone. The home ignition zone is an area that includes the home and its immediate surroundings, which, if properly conditioned, can save the home during a wildfire. The home ignition zone regards property from the perspective of a wildland fire. A house is no longer a home. It is potential fuel, and everything surrounding this fuel is a potential heat source that could ignite it.
The home ignition zone determines the vulnerability of our home to wildfire, and that home ignition zone extends out a couple of 100 feet at most from the house.
Protecting a home begins by reducing the flammability of the home itself and the surrounding property. For example, by switching to flame-resistant roof materials. Thinning out trees can stop crown fires from spreading from canopy to canopy until it reaches the home. And clearing the zone of dry vegetation and flammable objects can eliminate heat sources that might form a path to the home. The object is not to entirely eliminate fire within the zone, but to ensure that fires that do start can't burn long enough or intensely enough to ignite other objects. The goal is simple: reduce the fuel, and the fire cannot continue. The intense heat of a fire on the ridge generated swirling winds that carried and dropped burning embers on homes far in advance of the flames.
We were right here on this road, so we were fairly close to this crown fire, a couple of 100 feet from this crown fire, and yet the radiation wasn't so intense to where it would have ignited the wood walls, because we're more vulnerable to the heat than what wood walls are. But there was this tremendous blizzard of burning embers coming out of this intense fire.
Severe wildfires commonly generate firebrand blizzards. Like the Patty Canyon fire, these blazes quickly race out of control. Firebrands are swept along fast-moving currents and deposited onto homes ahead of the fire, causing them to burn to the ground, even though the crown fire never came near them. Because firebrands are so small, we tend to ignore them and instead focus on the large flames. When fires broke out in Bel Air, California in 1961, 95% of all homes with non-flammable roofs and a 30 to 50-foot buffer from fire survived. The 1990 Painted Cave fires in Santa Barbara, California experienced similar results. There, 86% of homes with non-flammable roofs and 30-foot separation from flames survived, while other homes burned. Scientists like Jack Cohen have dramatically changed our understanding of wildfire. We now better understand how homes ignite, and we possess the remedies to save our homes. But that raises a question. Why should people take responsibility for their property? Isn't that the job of firefighters?
We can't rely on fire agencies to either keep the fire away or to keep our house from igniting. The wildland firefighter's job is to contain the wildfire. They go out and they remove vegetation to keep the fire from spreading, and thereby we contain the fire that way.
Wildfires can quickly become so overwhelming that firefighters are unable to protect individual homes, so the burden must fall elsewhere.
When we think about how homes ignite during wildfires and realize that it's the home ignition zone that determines the vulnerability of our home, and that by and large we own that, and that we're the only ones that can do something, that means that we are going to have to participate in this problem as homeowners.
The good news is that home survival isn't an all-or-nothing proposition. We don't have to completely rebuild our homes or re-landscape our yards. The goal is to minimize ignitions during a wildfire in order to contain the fire. Preparation, however, must begin long before smoke appears on the horizon.
We've got to do things before the fire ignites. Those things like seasonal cleanup of needles around our house, changing the roof, thinning out the forest that's next to our house. Those are the kinds of things that we can't do when the threat becomes imminent.
Saving homes demands a fundamental change in our way of thinking. To coexist peacefully with nature, we must learn to be compatible with wildfire. We must realize that wildfire is inevitable in nature, but that destruction of our property is avoidable. We can save our homes. It's up to us.
Peak rooftop fire suppression sprinklers are designed to automatically fit any pitch roof. As seen in the video, they will sit and stay by themselves on just about any surface. Each sprinkler puts out approximately 5 gallons of water per minute and covers approximately a 45-foot diameter circle. Remember, in a wildland fire situation, most house fires are caused by blowing and falling hot embers. Let the Peak Rooftop Fire Suppression Module help save your home when wildfire strikes. Don't delay and order yours today and be ready. Cost is $39.95 per module. Call Chris at 541-840-8040 or Steve at 541-944-5078.